Hey guys, this looks like a fun one. We're given a semicircle and two other semicircles, and it wants us to find the area of the large semicircle. We're also given this line here, which I'm assuming is tangent here. This is day 8 of the 2025 Advent calendar. For the month of December, we're going to try to solve 31 Katrina Ag puzzles in 31 days. And as of right now, I'm about 2 weeks behind schedule. If you want to try this one on your own, pause it right now, because I'm going to solve it in 3, 2, 1. For the first step, let's look at this angle here. It's an inscribed angle that's sitting on the diameter of a circle. That means it's a 90-degree angle. Anytime an inscribed angle sits on a diameter of a circle, it's always a right angle. And then from here, let's mark the center of this semicircle, and we can label the radius R. And this will also be R. Now from here, we do have enough information to solve for R. Since we know that the area of the semicircle is equal to 4, we can say 1/2 of pi r squared is equal to 4. And then we could solve for R. But I'm going to wait on this because I don't know for sure if we're going to need R. And now for the next step, from this tangent point, let's draw this line perpendicular to the tangent line. And we know this will go through the center of this semicircle. And the radius of this semicircle will be the same thing as the radius of this semicircle. So we can label this R. And then from here, let's connect the two centers of our semicircles. Anytime you connect the centers of two tangent circles, the line will always go through the tangent point. And now we can label this radius R and this radius R. Let's copy this down here. Since these two sides are perpendicular to the same side, they will be parallel with each other. And then we know that this is a parallelogram since we have one pair of opposite sides congruent and parallel. And in a parallelogram, opposite angles are congruent. So this angle will be 90 degrees and this angle will be 90 degrees. And then from here, I want to focus on these triangles. Since this angle is right, this angle will be right. And since this angle is right, this angle will be right. And then we can label this angle theta. And then this angle is corresponding to this angle, so it will also equal theta degrees. Here's the notes for corresponding angles. Anytime you have a transversal cutting through two parallel lines, these two angles will be congruent, and they're called corresponding angles. And now we can focus on these two triangles. Since they have these two angles congruent, these two sides congruent, and these two angles congruent, these two triangles will be congruent. That'll be by the angle side angle theorem. Anytime you have two triangles with a corresponding angle, another corresponding angle, and the side in between them, you know the two triangles are congruent. And then since we know these two triangles are congruent, these two sides will also be congruent. That's known as CPCTC. It stands for the corresponding parts of congruent triangles are congruent. And now looking up here, this is equal to this. So each of these are going to be equal to a radius of the semicircle. Let's label them with big R's. And now we can write a formula for the area of our large semicircle. It'll be equal to pi big R squared divided by 2. This looks important. Let's put a box around it. And now let's try to find big R. Next thing I'm noticing, we can do Pythagorean theorem for this triangle here. It'll be R squared plus the quantity 2R squared equals big R squared. Then on the left-hand side, we can copy down the R squared. This term will become 2 squared R squared, and 2 squared is equal to 4. R squared plus 4R squared is equal to 5R squared. And then on the right-hand side, we can bring down the big R squared. And now we have a value that we can plug in for big R squared. We can plug in 5R squared. Let's switch these, and now we have the area in terms of this R squared. And as we mentioned earlier, we know how to solve for this R. So it ends up we are going to need to find this R. Let's multiply both sides of the equation by 2 over pi. On the left-hand side, all of this will cancel out. So we're left with R squared. And then on the right-hand side, 4 times 2 is 8, so we have 8 over pi. And now we're ready to find the area of our semicircle. In the place of this R squared, we can plug in 8 over pi. And then this pi and this pi will cancel each other out. 5 times 8 is equal to 40, and 40 divided by 2 is 20. We can give it a label of square units and put a box around it. And that is the answer to our question. In this given diagram, the area of the large semicircle is equal to 20 square units. How exciting. And this is the question for day 9. We're given 3 squares inside of a triangle. We're also given that this distance is equal to 6. The question's asking what is the sum of these two shaded areas. This looks like it'll be a fun one. How exciting.